record on this computer. Okay. So okay. Let me make sure that this is going. All right, can everybody hear me on there? Because I don't know if you're fault. Can everybody hear me on Zoom? I need to know this. Okay, great. Because I had to completely reformat my computer multiple times yesterday because I was trying to get Linux to work, only for Zoom being the only application that Zoom couldn't work on. Sorry, Zoom was the only application that Linux couldn't work on. And for those of you who care, it's not anything wrong necessarily with Zoom. It works plenty fine for other people on Linux. It just happens to be an issue with my particular model of laptop, specifically relying on the Optimus or Primus technology of having an integrated graphics card as well as a discrete graphics card. So yeah, apparently Zoom just totally freaks out when there's two graphics cards in the latest version. And I can't downgrade and use a previous version of Zoom because Temple won't let me log in then. So so yeah, oh well, I was hoping to do Zoom, but I was hoping to show you all the beauty of using Linux because I love Linux. But I did find out that that Windows PowerShell. Oh, okay, it's not showing. So display settings, right? Display setting. This is a duplicate on 1 and 3. That's what you're doing. Okay, revert there. No, it's all wrong. Duplicate on 1 and 3. Keep changes. That goes there. Excellent. You figured it out. Good job, Windows. You get a cookie. You get lots of cookies because you're online all the time. All right. So anyway, what I found, what was beautiful though about like a couple of weeks ago is that you can run graphic applications from Linux. Let's see. Sorry, let me log into my Linux virtual machine just by typing it in, and now we're there. And then I can yell at it to please do to use a graphical application, a Linux graphical application, and it does so. This isn't Windows, that's a Linux application. You can tell because it's got Penguin down there. Yeah, Windows subsystem for Linux is great. It's great. So I expect to be, experimenting with that over the coming kind of weeks and months. No, this is a virtual machine. This is a virtual machine built into Windows. Windows subsystem for Linux is like kind of Microsoft efforts. It's one they've been making a great strides towards doing a lot of open source technology recently with the Linux is an operating system, not necessarily a language. Just answering the question there. So, and why should you care about Linux? Because like most of the web servers run it. That's why. But Microsoft has been really good about open source technology recently with purchasing GitHub, with releasing VS Code. VS Code is amazing, right? I think a lot of you use VS Code. And then they have the Windows subsystem for Linux so that, if you can run Windows and don't have to dual boot and stuff. Of course, there's fears of that they're using their triple E tech strategy, which is something that Microsoft has done in the past, which is they embrace a technology, they expand it with Microsoft only add-ons, and then therefore they extinguish the previous editions because those are no longer compatible and everybody needs to use the things. This has been done with web browsers, but hey, big companies are going to do the big company things. But for right now, it's actually pretty nice that Microsoft has been, playing nice and being open. And they also have a reason to be more open because, Apple exists too. It's been interesting to see like the makeup shift throughout my teaching for basically it's like been like clearly half and half now. Yes.
On Linux for the Windows Linux, I couldn't run Matplotlib on it, to be honest. Like I tried to grab something with Matplotlib.
Interesting.
It didn't show up for the subsystem.
Interesting, but does it? I mean, you can
I ran other like.
But does it not output? Anyway, that's neither here.
It just doesn't show up.
I mean, but like on Windows with Windows subsystem for Linux, you should be able to read, I think, the file system. But regardless, anyway, so we're moving on. I believe I mentioned something about an exam. I didn't say it was this week, right? I said it was November 4th, right? Right, okay, good, because I'm like, I'm not ready to write 2 exams in 1 week. I've got 10:51. You guys are safe. You know, so again, though, you'll expect to get your practice exam. Expect to get your practice exam in the next couple of, by the end of the week. Oh, come on. Canvas.temple.edu. I also got a number of emails last night that I just didn't respond to, asking for extensions on the index lab. Yeah, just get it in when you can, please. If you take another couple of days or 2 about it, I'm not going to really care. Okay. So, and those for those of you who are done with it, please, help your friends, especially with the print index, because that can be counterintuitive about how I've done it. But you don't, if you're doing print index, you don't necessarily want to use the strategy I use for printing out a tree. You do want to go in order. You do want to do an in order ordering of the tree, but you don't want to do what I did. Again, for November 4th, the exam will be 2 parts. You'll have the electronic part, but this time we're going to do the group part on paper. Okay, just because, and there'll be slightly different questions. The paper may just be you do it all on paper and just have to rely on nothing but like handwritten notes you've got, but I don't know, I'm still deciding between that. Where's on this part of, on the electronic portion, if you're on a computer, you have access to all the computer like stuff that you would think were reasonable. Yes.
Would you deduct points for like syntax error or like just like wrong formatting on the papers? Not really.
I try not to deduct those points on the actual exam as well. The most, if they're particularly if they're egregious, like maybe a point, but like I don't try to be. I assume on exams that people are trying to move fast, and that, if you actually had the resources to check the things, you would actually be fixing those things, but you're missing time. So now I want to talk about our upcoming assignments. So the next big assignment coming out is Cheater's Hangman. And you'll see that I've given you a quite extensive amount of time to work on that. Okay, which is that it's due here. Let me there. Glare, right? It's due November 7th, which is pretty far from now, right? All things considered. That's because it's a much larger program than normal. But it relies off of basically and you'll want to read the PDF. I think I'll go into that in more detail on Thursday, since people are still finishing up the index tree. But the idea here is that but I should also point out, because I don't have this written down, if you can do Hangman, but you can also do one other game, which is Wordle. You can do a Wordle version of this instead, because the same strategy applies. So what do I mean by that? Well, somebody wrote this program and he let Absurdle, and he let how he does it as an exercise to the user, but I know how he does it because it's the same thing that we use for Hangman. So who here is familiar with Wordle, right? Hopefully everybody got familiar with it during the pandemic, right? Basically what you're trying to do is that you're trying to guess the word made up of 5 letters, and then it's got the mastermind way of telling you, okay, this letter is in the right place in the right position, and this letter is isn't there, and this letter is in the wrong place in the wrong position. So I could try quest, which I think is a terrible starting word, but hey, and it tells me I got them all wrong. What is the chance of that? Okay, so apple, even though we know that's going to be wrong. Okay, it tells me that an A is in the right place. Sorry, it's in the wrong. The word has an A, but the A is in the wrong position. Barks. Okay, it tells me the A is there, but it told me everything else is wrong. And we know that it can't be a P, so we're getting let's see. I'm honestly stumped about this. So I'll hit random guess down there. Begin. Okay. And another random guess. Theme. I'll hit give up, and it's going to tell me that the word was daddy. Actually, don't give up. And it says And then I hit give up again though. And now it tells me the word is caddy. Actually, don't give up. I'm going to give up again. Jazzy. So as you can see, it's not being completely honest, right? It's betraying one of the fundamental principles of Wordle, which is that the computer has chosen a word and you're trying to guess it. And this is going, I'm not choosing a word. That would increase your chances of winning. And that's exactly what the Cheater's Hangman program does. We don't choose a word. We never choose a word unless we're actually forced to by the user. Instead, we rule out what words are valid and what's not valid. And then we respond to the user with one goal in mind, which is extend the game as long as possible. Because if we extend the game as long as possible, then the user has the most chances to lose, right? Right. The longer the game goes on, the more likely it is going to the player loses because they'll run out of whatever arbitrary number of guesses we set up. Okay. And that's what's going on here. Now, how many of you did Cheater's Hangman in Professor Fiore's class, 1068? Yeah, one. Just one? Did he do it in spring 2022?
No.
Awesome. Okay, he used to do this one. If you've done it before, welcome back to it. But this time you're doing it with hash maps, which means that it's all the more interesting. Yes.
I took his class in fall 2021, and he didn't do that either.
Interesting. Okay. Because that's one he's done. Oh, I've got a message in chat. Yeah. So the idea here is, again, what we're going to be doing is we're going to be making a program that kind of, cheats. So before you start this, what I want you to do is read up on and watch the videos on how on how my hash tables work. Okay. And then also read up on the document I hand out. I'll go over it again as though people hadn't read it, because that's generally, I find two exposure two different ways works best for understanding, as well as giving you some starter code on Thursday, okay, to help you organize it. Or at least, and by starter code, I mean, I'm going to give you the function names and then I'm going to tell you, and then I'll leave it to you to figure out how they go together, right? Because I find that normally helps students. But it's a lot of fun, and if you want to just clone this absurdal game instead of doing a hangman, you're more than welcome to. It just has to be on the, it doesn't have to be on the web. We're assuming it's on the console. The other thing about hangman is the hangman game is that you don't need to draw your little stick figure characters. That's unnecessary. You can just tell me how many guesses you have left. Okay. All right. So that's how that will work. And then of course, I'll send out the practice exam. We'll go over the practice exam on not this Thursday, but next Thursday, so that you have plenty of time. But again, pretty much the practice exam will heavily cover, even though it requires recursion, we're not going to really test too much from the recursion. I might actually take the chance to do that in the group exam, but that's an idea. But for the most part, the exam itself covers the primary focus of the modules is going to be the trees and the heaps, right? So you've got your tree functions over here. You got your heap video, and then you've got your heaps. But a lot of it's about the trees, making sure you know how trees, because trees are a very popular data structure there. Okay. All right. And last thing before we continue, how many of you are currently looking at internships and stuff? Like trying to get internships? Lots of you. Okay. So once you complete this class, I would say I would say go ahead and try, shooting big at this point. So any kind of FANG company, you'd be surprised. They don't really look at what's traditionally considered top tier schools, because they found in the past that talent is basically everywhere, and it's not just being in those top end high schools that you have to pay lots of money to go to. That's all.
You have to know someone to get it to.
Yeah, that helps. That helps. But regardless, they find that basically, but Honestly, I would try it. And one of the best resources I found for trying and doing programming interviews is this website, which I probably have shown you before, but if I haven't, I just want to show you this one because a lot of people say it's valuable, which is Pramp. This is, unless they've changed it, this is a free service. What it is that it allows you to, it's peer-to-peer mock interviews. So doing mock interviews with each other, basically solving problems. What they'll do is that, and as you can see, I did this when I was back at Georgia State University. So like, for instance, this is the question that I'm given a question that I was asked, and then you ask a question. You don't have to bring the question to ask. They provide the question, they provide the hints. So for instance, I was given this question: given the root of binary search tree and a number called num, implement an efficient equation, find largest smaller key that finds the largest key in the tree that is smaller than number. If it doesn't exist, return -1. So for number 17 and the binary search tree below, so your function should return 14 because it is the largest number that is smaller than 14. So in other words, this is just using the algorithm we use when we are trying to find the next largest successor. Sorry, the next successor by going one to the left and going all the way to the right. And the language, they provide the tree class, right? I think there's my answer there. Nope, that's insert, I believe. Yep. They provide your answer for it, and then they provide you a function to write, but they also have it set up so you can run it in any language. You'll be paired with somebody. The idea though is you're paired with somebody in the language you prefer. You basically say, hey, the way this works is that you say, hey, next, this is let me find a time when somebody else is available, right? And that's it. They give you a certain number of free credits, and then it works on a pyramid scheme after that, which is you get a free credit for every 3 people, once you invite another person and they sign up. And after doing that for 3 people, you get unlimited interviews. So like I said, pyramid scheme, or sorry, inverse funnel. But regardless, I did this a few times. It was pretty good. It's good practice, but a lot of the things that you'll see here, like this matrix spiral copy, which is one I was asked, which is simply given this input matrix, we want to output it in this order: 1, 2, 3, 4, 5, 10, 15, 20, 19, 18, 17, 16, 11, 6, 7, 8, 9, 14, 13, 12. That's kind of a problem that's annoying, as you said, no matter what skill level you're at, right?
I think there's only one way to tackle it.
I'm sure there's plenty of ways to tackle it, but it's just like,
There's only time limits.
you're given, there's a time limit for your algorithm to run, right? If it's not going to complete it in a certain order,
5 seconds.
50 seconds, yeah, 5 seconds. It should run in 5 seconds. There's no reason why it shouldn't run in 5 seconds. But anyway, it's basically an hour-long session, half for you, half for another person. I find this kind of to be invaluable. The other thing to know, because we're coming up on Christmas time in just a bit, I know it's actually quite far away, but Advent of Code come December. Advent of Code. I don't know. I said 2. You can review the previous year's worth, but basically they're essentially only you can help Santa save Christmas by solving these programming problem kind of things. And it's got a storyline, and it's actually like a little bit of fun too. And so, but they're programming kind of problems. They're good ways to practice your skills. That's how you get good for those kind of interviews that you want to do. All right.
You didn't mention the infamous one, leak code.
Oh, leak code? I've never used that. I wouldn't know. I think it's okay.
It's like every other.
Yeah. Advent of Code. Advent of Code. Finally, my personal favorite, if you haven't figured it out, of course, is Project Oilline. because it requires you to learn some higher level programming techniques that you might not have had the chance to be exposed to. So for instance, let's see. So this one doesn't seem not too bad. Work out the first 10 digits of the sum of the following 150-digit numbers, right? You're just doing addition. How hard could that be? It's not hard in Python, let me tell you that. But in Java, what?
It's very good.
They're bigger than longs.
2 to the 32 or whatever.
They longs go up to 2 to the 64, or sorry, 2 to the 63rd minus, sorry, they go up to 2 to the 63rd because of negative numbers. You can do unsigned, which gets you up to 2 to 64, but these are still bigger than the numbers you would normally have in Java. Instead, the way you have to figure out, either you have to roll your own solution, or you have to know, wait, does Java have a way to do numbers that are bigger than integers or longs? And the answer is yes, they have the big integer class, which does things that are arbitrary size. So it's these kind of problems give you exposure to those things. Another one, let's see, the lattice paths one, which is great for learning dynamic programming, starting at the top left corner of a 2x2 grid and only being able to move to the right and down. There are exactly 6 routes to the bottom right corner. So you're starting here and you've got only 2 moves, right and down. Boom, 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 boom. There's 6 possible paths, right? For that lattice, for that grid. But again, you can only move to the right and to the down. You can't create any cycles here. How many routes are there in a 20x20 grid? The answer is lots. It's actually lots. Once you solve a solution, you gain access to a forum specific for that solution, where people will share their absurdly optimized solutions done in like assembly or something, because they're maniacs. But in all seriousness, like this is like kind of a problem that's actually kind of hard to figure out unless you learn how to use what's called dynamic programming. So these are kind of problems that are worthwhile, and they really help. And as you've seen, by the fact that I've made you do some, that they do pull from other things. Last one I'll show you is this one, because I find it incumbent to introduce this to every single student in case one of you has some crazy solution. So the following iterative sequence is defined by the set of positive integers. And so if you're at n, then the next number in the sequence is half of n. If n is even. So if the current number is 8, the next number is 4. Okay. But if n is odd, the next number of the sequence is 3n plus 1. Okay. So if we start at if we use that rule and we start at 13, the next number in the sequence is 40, because 3n plus 1, 13 times 3 is 39 plus 1 gives us a 40. 40 is even, so we use now the above rule. It's even, different rule if you're even or odd. So we divide 40 by 2 to get 20, divide 20 by 2 to get 10, divide 10 by 2 to get 5. We're at an odd number now. So we do 3n plus 1. So 15 plus 1 gives us 16. And then we divide by 2 to get to 8, to 4, to 2, to 1. And then once you're at 1, you'll see that it kind of once we stop at 1, because at 1, we hit a cycle where we would go 4, 2, 1, 4, 2, 1, 4, 2, 1. Right? 3 plus 1 would be 4. So, and then 4 divided by 2, 2 divided by 2. So we define 1 as a stopping point. Okay. It can be seen. Okay. This sequence has 10 terms. Although it has not been proved yet, it is thought that all starting numbers finish at 1. There is not another, that basically 1 is always the stopping point. There's no other loop than basically being at 1 and going to 1. This has not been proven yet. It's an outstanding problem in math, meaning that it's yet to be solved. There's currently a standing 500. I think the state of Paul Erdos might honor the standing $500 prize. I don't know. Yeah, I know. That's a joke. Actually, if you solve it, you'll earn a lot of mathematical accolades, but nobody's been able to prove it yet. It's one of those things that is just kind of you can try a lot of time on. There's been a lot of stuff. People have like empirically checked using computers very, very large numbers, but it's just like one of those interesting problems. in mathematics that, you need kind of computers to solve. Anyway, they're wondering which number under 1 million produces the longest chain, and 837,799 produces the longest chain of numbers for numbers that start below 1 million. Anyway, so that's enough for me prattling on for today, but I wanted to just introduce you to since I know a lot of people are like looking at doing internships right now or thinking about doing interviews. I just figured that it would be useful to kind of tell people and deal with that. All right, any questions before I let you get to work? All right,